Welcome to this series of training videos on GHS model creation. Tutorial 220 will focus on model organization. Now, by model organization, we're talking about the actual physical, logical structure of how does GHS organize hull models? How does it organize the vessel model? And it's important to understand this organization because it's important to understand both the language of GHS, the nomenclature that they use in the help files, and then it's also important to understand the concept because that will really help simplify your own organization as you build up a model. First, a quick disclaimer so that I don't end up with a lawsuit. This presentation is for instruction only. It's not to be used in engineering or construction. I am not a representative of Creative Systems. This presentation is not endorsed by Creative Systems, and I make no claims of accuracy to the latest version of the GHS software. If you're interested in the official training for GHS, contact Creative Systems. You can look up their website, www.ghsport.com, or contact them directly via phone or email. Right, so the first thing we need to talk about for model organization are the syntax rules. Now, initially we've talked about syntax in terms of commands. Now, for model creation, there's a few other rules that you have to know. Number one is part names. This is one of the throwbacks from the DOS origins of GHS. Part names can only be 1 to 12 characters long. So you'll see they're always very short part names. And then similarly, shape names can only be 8 characters long. Now, don't worry. I'll go into in a second what parts and shapes are, but just remember all of these have to be very, very short names. Right, so what are parts and shapes? This gets into the heart of model organization in GHS. So all vessel models are a collection of parts. Parts are made up of components, and components are have one shape for each component. Now, I'll get into a second of what each of those do, but keep that in mind that every vessel in GHS is a collection of parts. You can have more than one part, and every part can have more than one component, and every component has one shape. So the way that breaks down is you can see you have, for example, if we had 2 separate shapes, that shape could then be used in multiple components or in just one component, and then those components feed into parts. Now you can see a part can have multiple components, and each component can be pulling from a different set of shapes. So the important thing to remember out of this is that parts can have 1 or more components, and a component can only have 1 shape. So each component will only feed from 1 shape, but that single shape could be used in more than 1 component. I know it's a little hard to think of at first when you work out all the numbering, but just look at this diagram and that explains pretty clearly what all your options are for structuring and combining components and shapes and parts. Right, so what are shapes and components and parts? Well, let's start at the most basic level, which is a shape. A shape is basic geometry only. We're only talking about the actual section shapes, the physical structure of whatever your thing is. So we're talking XYZ coordinates here, and that's it. That's all that you have in a shape. Now a shape then feeds into a component, and a component is basically that shape information plus some extra bits. And now we're start talking about properties of geometry. And that's what a component has, is it's the geometry plus the properties of that geometry. Things like the permeability of a space and the position of that space relative to the total vessel coordinate system. So you can think of it as shapes, first off, each have their own coordinate system. Kind of. You can create a shape in the vessel coordinate system, but the idea is also that the shape could be in its own coordinate system, and then the component specifies the position of that shape in the vessel coordinate system. And then those components feed into parts. And parts can think of as components plus physics properties. Things like, if you're talking about a tank, the density of the fluid that is going in that part, its flooding status, whether it's flooded or not, any sounding tubes. And so, just think about that parts are where you finally factor in all the physics. And you can have 3 different types of parts in GHS. You can have hulls, tanks, and sails. And we'll go into what each one of those mean. Okay, now the next thing you also need to know about model organization is a little bit of the basics of how that all fits together. First off, GHS only works with transverse sections. So all of those shape definitions will be based on transverse sections. So you'll have a series of YZ coordinates at a fixed X plane. Don't try to define longitudinal geometry in GHS. You might talk to some GHS gurus that will tell you it is possible. They'll also tell you it's very, very tricky. So unless you've been doing it for a while, don't try to define any longitudinal geometry by switching your coordinate systems or anything like that. And also, it's usually more trouble than it's worth. And then, of course, you got to remember that GHS is using the American coordinate system at the heart of GHS anyways. Which positive X points aft, positive Y points to starboard, and positive Z points up. And now the reason you have to remember that is because you'll see a lot of parts and a lot of shapes, a lot of parts and a lot of components will have a .S or a .P on the end of their part name. GHS, that means something to GHS. It's not just part of the name that you assign it. If you type a .S or a .P, GHS will interpret that as shorthand for specifying the sides of the vessel. And so if you type something that has positive Y coordinates and you give it a .S, GHS says, okay, that's on the starboard side, that's positive Y using the American coordinate system. Now, if you take that same thing, that initially it had positive Y coordinates in its section definition, but you put it into a part name that has a .P on the end, GHS will flip that section. It will actually take all of those positive Y coordinates and turn them negative to put them on what GHS thinks is the port side of the vessel. So just remember that of how that feeds into your coordinate system naming. The other one here that you can also use is a .C extension, which stands for centerline. GHS will take an object and mirror it to both sides of your vessel. That's really, really handy for a hull, for example, so that you only have to define half of your hull shape. Okay, time for a little bit of homework to exercise that knowledge. I want you to create a model in Rhino and just simple boxes, and you're going to use the command attach GHS data to attach those parts. And this is really useful in Rhino if you have it available, because Rhino has the structure of parts and hulls and tanks and sails already built into it. And it actually understands the concept of shapes feed into components, which feed into parts. So you can add geometry into the attached GHS command, and Rhino will already set up that structure of parts and shapes and components. Parts and components and shapes. And so once you do that, try that with just a few simple boxes. The geometry doesn't really matter. So that's why I say boxes, because they're quick to build. But once you've attached a couple of them, identify the part, the component, and the shape for each item. Try to create a hull part, a tank part, and a sail part. Okay. Well, thank you very much for watching. I hope you have found this informative. You can find the homework and more tutorials like this on dmsonline.us. Thank you very much.